Good morning. My topic for the assignment is HR attrition, and here we have the raw data with which I am going to work. For the selected columns, I have used to make the dummy variables, and for the columns like attrition, business travel, and department, I have used this formula to convert the qualitative text into quantitative ones, and this formula is used for the continuous variables. Here we have divided the variable into 3 ranges and have only shown 2 for the dummy variable. The formula is used to convert these continuous variables into binary categories. And now we are using the rand function to randomly assort these datasets. I first use the filter option here, and then I'm now using custom sort, and I'm sorting it through the random column from smallest to largest so that all the data rows are now assorted from smallest to largest, and it is in a random order. Now I'm gonna select the data for the training set and the test set. So for the training set, since it's an imbalanced data, as we can see, there are only 237 yeses among the 1470 data. So now we're taking the 80% ratio for the training set and then 20% ratio for the test. We're taking the amount of no's equally, that is 189 for the training set, and for the test set, it's the 20% of the total data, and we have 246 no's. Now moving towards the logistic regression model, we have put intercept 1 for each variable, and that is named as model coefficient. And now we're doing the formula for linear combination. This formula is used to determine whether an employee is staying or leaving depending on the z-score that it creates. At first, I had selected 0.1 for each coefficient, but then later on, I used 1 for all of them for a better result. And then I use a sigmoid probability formula to convert the linear score into a probability between 0 and 1, which actually helps us to show the probability of people leaving into percentage. Then we use the log probability formula. By using log, we basically add scores together for the Excel solver to find the best coefficients. Then we use a sum function to find out the maximum likelihood, and here I change the coefficients into 1. And then I run the solver. Here we made the unconstrained variables non-negative unticked mark because it allows the coefficients to be negative, which is important for identifying the retention factors. And then for the model test, we use the sheet from the test set, and now copy pasted the solver coefficients and then found out the linear prediction and probability sigmoid using the previous 2 formulas we use in the logistic regression. And here we found out the maximum and minimum prediction from the probability sigmoid of the model test sheet. And then to find out the probability cutoff for attrition, we use the sequence function to create an array. It lists a dynamic threshold from 0 to 1, which is essential for the RSA curve plotting. Then we find out the TPR and the FPR. We use the if error and let function to calculate the TPR and the FPR. This actually shows the proportion of actual levers correctly identified by the model at a specific threshold to ensure the high-risk employees are not missed. And then we use the same formula for the false positive rate too, but instead of using the 1, we use 0. And we also change the names The FPR actually measures the model's tendency to cry wolf, which is basically the percentage of employees who stayed but were incorrectly flagged as leavers, and it helps us measure the cost of false alarms. So the if error function was used at first to ensure that if the math results in something divided by zero error, it will help to show only zero instead of a error. And then the let function actually allows us to name our variables so the final decision is easy to read. And then we calculate the true positives using the countif function. And here we have the first column, which is the predicted probabilities. And then the second column, which is actually the column B, is actually the outcome. And then we calculate all the positives using the count if function only. And then the final calculation is done by dividing true positive value by all positive value. It shows us the correct guesses divided by the total actual events, and it actually gives us the true positive rate. For the false positive rate, both the if error and let functions stay the same, and the ranges also stay the same. The names are changed because now we are going to first calculate the false positives using the countif function again, and then we calculate the all negatives, and during the TPR we used the condition 1, and now we're going to use 0 instead of 1, and then we divide the false positive value by all negative value. It actually shows that the percentage of loyal employees who were incorrectly flagged as risks. Here we are creating the ROC curve chart using the scatter plot, and here we're changing the axis. The FPR is a x-axis and the TPR is a y-axis, and then we calculate the AUC using the trapezoidal rule, which is basically the area under each segment of the ROC curve added to provide a single score that overall represents the model's predictive power. And lastly, we calculate or find out the cutoff variable ideal for this model using the confusion matrix. And here we're using the countif formula to find out the true positive, true negative, false positive, and false negative values for the cutoff variable at 0.5. Here I have calculated the sensitivity and FPR, and I then found out the JSTAT by subtracting FPR from the TPR, and then we run the solver where the objective is maximizing the JSTAT by changing the variable cell, the cutoff variable, and then we add the constraints where it cannot be more than 1 and it cannot be less than 0, and then we run the solver. After running the solver, I then found out the accuracy, precision, and the specificity by using the formulas. Here, if I had used the F1 statistic, the result would be the same as I did using the JSTAT. I actually verified it behind the camera and then found out that both the values, the cutoff variable, is the same whether or not I use the JSTAT or the F1 score. The formula for the F1 score would basically be 2 times recall into precision divided by the summation of recall and precision. The model is pretty accurate. As we can see, the accuracy is 76.19%, and the area under the curve is above 50 and equal to 75% almost. And the cutoff variable for this is 0.5696. An AUC of 75% indicates that the model will correctly distinguish between an employee who stays or leaves 75 out of 100 times. So this is basically my logistic regression model for the topic HR attrition using a dataset from Kaggle. Thank you for watching and thank you for your time.